What's up guys, it's Imran Fiaz and today's video is on AQA AS Level Chemistry June 2016 Paper 2 walkthrough. Paper 2 walkthrough. Question 1, run expression for the equilibrium constant Kp. Expression of Kc, remember Kc, square brackets, product CH3, CH2, OH of the reactants to power of R. Well, all of these have got 1 mole, so don't need to worry about that. H2O. The units, well, it's moles per dm minus cube over moles per dm minus cube squared, so that will cancel out and I'll be left with 1 over moles per dm minus cube, which is moles to the power minus 1 dm cubed. Perfect. Equilibrium mixture contain this much volume is that, calculated for Kc. So therefore Kc is I'm just substitute these values in. Well, square brackets represent the concentrations, right? So moles constitute volume, concentration moles divided by volume. So the first thing on the top is ethanol. So 4.40 divided by 2 divided by the reactants power of R. Ethene 0.700 divided by 2 times by H2O 1.20 divided by 2, and I get 10.5 to 3 significant figures. Kc, obviously in the exam, sure you're working out, but you get the point how to do it. And then it doesn't ask me for the units, which I thought it would, but no. So 10.5 is only 2 marks. Question 2, you just needed to calculate value for enthalpy of combustion of methanol. So enthalpy of combustion, alright, equals Q divided by number of moles, and Q equals MC delta T, where M is the mass of water. So therefore Q equals the mass of water, which is 100 grams of water, 100 times by 4.18 C times by temperature change, which is temperature rise 38. So yes, 38. That's Q in joules, but I want in kilojoules, call my final answer in kilojoules, so it's going to be 15,884 times by 10 to the power minus 3 divided by number of moles. Well, moles equals mass over mR, where mass is the mass in this case of methanol, so it's going to be 214.02 minus 212.37. Then I'm going to do that over the mR of methanol. Well, methanol is that, so it's going to be 12 plus 3 plus 16 plus 1, get the moles, and then I'm going to do 15,884 times by 10 to the power minus 3 divided by the number of moles, and then I get delta H as 309 or 308.05, 308. But the thing is, the temperature rise, the increase, therefore it's going to be negative because it's exothermic. Therefore, temp increase. So find out Q, MC delta T, find out moles, delta H is Q divided by moles, use the correct units and you get minus 0.8. Just one reason other than complete combustion, whether it shoots value is different from that in data book. Well, it's an alcohol, so evaporation of alcohol. Evaporation, you can say, be even more specific, apply it to the question, evaporation of methanol. Well, either way, if you said evaporation of alcohol, you should get a mark. Insert, you should get a mark, yeah. Inserting each of temperature readings of that. Give all the certainty of that. Calculate percentage of we using the thermometer. Inserting each of the temperature readings is that. Temperature rise 38. Well, this is going to be then 0.5 because it says overall uncertainty is that 0.5 divided by temperature rise times by 100, which is 1.32%. Students said correctly that use of thermometer overall certainty for rising temperature was adequate for the experiment. Explain whether thermometer was adequate for experiment. Heat loss is more significant issue. Entropy of combustion is that, density is that, calculate heat energy release, and this much as that is burned. So I'm going to use density equals mass of volume. Therefore mass equals density times by volume, which is going to be 0.789 times by 500, 0.5 or dm cubed, so 500 centimeters cubed. That's the mass. Then I can work out the moles. Yeah, then I can work out the moles, which is the mass of the MR, which is just that. Copy and paste that. 0.789 of ethanol times by 500 divided by the MR of ethanol. Well, ethanol is that. So it's just going to be 0.789 times by 500 over 12 plus 3 plus 12 plus 2 plus 16 plus 1. Then once we've got the number of moles, find out the heat energy release. Well, delta H equals Q divided by moles. I want to find the heat energy release. Therefore, Q equals delta H times by mole. Delta H is 1371, so it's going to be 1371 times by my answer. I don't care that it's negative. I'm not going to include that. Therefore, my answer is 11757. Well, appropriate number of significant figures, we could say 11800 kilojoules. Three significant figures. Give that UPAC name for isooctane. 2 methyl group in the second one. Yeah, 2 then the fourth carbon. 2,2,4 dash tri-methyl methane, ethane, propane, butane, pentane. 2,2,4 dash tri-methyl pentane. Name the laboratory technique to separate isooctane from mixture of octane and isooctane. Fractional distillation, or you could say simple distillation, fractional distillation. Isooctane 1 with the lower boiling point. The lower boiling point boils first. Isooctane condenses, liquefies, and collected. One equation for complete combustion of isooctane in the form is C8H18 of isooctane, C8H18 plus O2. Complete combustion, so I know products purely carbon dioxide and water. 8, so I need 8 here. I need 9 here. 16 plus 9, so I need 12.5 over here. H18 plus 12.5, 8 CO2 plus 9 H12. Being in general terms, that catalyst works. Alternative route with a lower activation energy. Alternative route with a lower activation energy. The one equation shows pollutants react together in a catalytic converter. 2CO plus 2NO to N2 plus 2CO2. 2CO plus 2NO, N2 plus 2CO2. Explain why thin layer is used in this way. The idea that to reduce amount of metal needed and increasing the surface area. It's producing a larger surface area, or gives the catalyst a larger surface area. To reduce the amount of metal needed, that's what very thin thin layers used to reduce the amount of metal needed, and producing a larger surface area gives the catalyst a larger surface area. It's identify a region that could be used in chemical tests to show that oleic acid is unsaturated. Unsaturated, so it contains carbon-carbon double bonds. Well, Br2, bromine. And what happens, it goes from orange to colorless. You can say decolorized. But yeah, orange to colorless. Explain by determining the precise relative molecular mass of propanol, propane 2 and cannot be used to distinguish between samples of these two compounds. They have prop-2enol and propanol. C2, 1, 2, 3, 4, 5, 6, O. C3H, C3H6O, C3H6O. Okay, so they have the same molecular formula and identical MR. Use the spectrum to identify the compound. Okay, it's going to be prop -2-E-10. I don't know that because of the OH alcohol group, and that's the only one that's got this OH from the alcohol. So you could say bond use to identify carbon OH alcohol, be a bit clear because this has no, it doesn't. Yeah, OH alcohol, and then the wave number range 30 to 35, 50 centimeters per -1. Predict the relative boiling points of these three compounds from the highest to lowest boiling point. So I already know that propanol is going to have butane has van der Waals force, it doesn't have hydrogen bonds. Okay, so highest to lowest in terms of boiling points. So prop -2-ene-10 is greater than propanol, and propanol is obviously greater than butane. First things first, prop -2-ene-10 has hydrogen bonds. Propanol has permanent dipole forces. It doesn't actually have hydrogen bonds. I thought it did, but it doesn't. Butane has weak van der Waals forces. And then the strength of intermolecular forces, or hydrogen bonds, and that's stronger than dipole forces, and that's obviously going to be stronger than van der Waals forces. So highest to lowest, prop -2-ene-10, propanol, and then butane. Prop-2-ene-10 has hydrogen bonds. Propanol has permanent dipole forces. Butane has weak van der Waals forces. Hydrogen bonds greater than dipole forces, which greater than van der Waals forces. Yeah, prop-2 has the hydrogen bonds. Propanol, well, the idea that electron deficient hydrogen atom needs to be bonded to an NOF atom. Is that hydrogen bonded to an NOF atom? No, it's bonded to a carbon. Is that hydrogen bonded to an NON or an O or an F atom? Yes, it's bonded to an O atom. Therefore, that does have hydrogen bonds. That doesn't, and that clearly doesn't. It doesn't even have an NOF atom at all. Question 5. Write two equations of chlorine radicals react to ozone upper atmosphere. Cl dot plus O3 O3 arrow ClO dot plus O2. Wait, what? Yeah, and then ClO dot plus O3 to 2O2 plus Cl dot. Cl dot plus O3 to arrow ClO dot plus O2, ClO dot plus O3, Cl dot plus 2O2. Draw a splayed formula of chloropentafluoroethane. Well, methane, ethane, chloro, pentafluoro. So 5 fluoros. 1, 2, 3, 4, 5. And that's chloropentafluoroethane. Spray my 1,1 trifluoroethane does not lead to depletion of ozone atmosphere. Does not contain this chlorine. Does not contain Cl. Right, two equations represent propagation step conversion of this into that. So CHF2CH3 plus a chlorine. Is it? No, it reacts with fluorine in free radical substitution. So I'll just jump into chlorine free radical. Because generally is that, but in this case it's not. I'm going to obviously form HF plus what else am I going to form? Well then, I'm going to form CF2CH3 dot. Then I'm going to have CF2CH3 dot plus F2 to form, and I'm going to reform the F dot, and then I'm going to also have CF3CH3. CHF2CH3 plus F dot to CF2CH3 dot plus HF, CF2CH3 dot plus F2 to form CH3CH3 plus F dot. Calculate number of molecules in this in the refrigerator. So first thing I would do is find out the moles, which is the mass in grams. 1, 2, 3, 1410 divided by the MR of that. And then times by Avogadro's constant 6.022 times by 10 to the power 23. So that divided by 84. So 1410 divided by 84 times by 6.022 times by 10 to the power 23. 1.01 times by 10 to the power 25. And that is the number of molecules. The grown concerned by the use of this as refrigerant as its greenhouse gas give one reason why bonds in this absorb infrared radiation. C double bond O bonds are polar. No, but it does say such as carbon dioxide and trifluoroethane. That doesn't contain C double bond O bonds, so I can't really say that. You say the bonds, we could say, yeah, just the bonds are polar. Bonds are polar, or we could say they stretch. Bonds are polar. Yeah, bonds are polar. As bonds are polar. Just going to form the propane 1,2-diol. So methane, ethane, propane, and I'm going to have a diol. So it's going to be I'm going to have, let me get rid of this. Methane, ethane, propane. I'm going to have the HO here and the OH here. That's it. OH on the first carbon, OH on the second carbon. Find the equation for the oxidation reaction of this and the reflux, and it is, that's the structure of propane 1,2-diol. So it's going to be CH2. No, but just say show displayed form of the organic product. Let's just say this then. C3H8O2. So C3H8O2 plus O. But what I'm going to form is so I'm going to form this HOC double bundle C double bundle, and then it should be CH3 there plus 2H2O, and I'm gonna have 3 there. Just made that draw a label diagram. Show you setup apparatus for refluxing. In this question, I'm just going to skip just how well you memorize the diagrams. And the more scheme is just saying flask with condenser vertically above it, flask condenser label. It's not going through any like a drawing or a diagram. Suggest why granules prevent bumping, prevent formation of larger bubbles. Or yeah, you could say form smaller bubbles. Draw structure of a different organic product form an acidified potassium dichromate is not in excess. When it's not in excess, well, then you can form C double bundle HO there you go. CHO double bundle that, and then that. Draw structure of Z 3-methyl pentuene. So you can see here 3-methyl pentuene. So we've got carbon-carbon double bond. We've got a H and a CH3, and then we've got CH3. So I've got a CH3, CH2, CH3. We've got that. They're on the same side, so something like that. Perfect. One thing but this case, no, actually, CH3 would be here, and then the hydrogen would be here. Z-3-methyl pentuene. There we go. And show the bond here, CH2/CH3. Name down the mechanism of formation of this, from reaction of this to this. It's going to be electrophilic addition. And then I've already drawn out 3-methyl pentuene. So C1C. Actually, I'll just do it in this format. So you've got methane, ethane, propane, butane, pentane. I've got a methyl group here. Hydrogen here, 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 hydrogen here. 3-methyl, 1,2,3-methyl pentuene, methane, ethane, propane, butane, pentane, hydrogen bromide, hydrogen partial positive, Br partial negative. A formation of 3-bromo, 3-methyl pentane, 3-bromo. First things first, that goes. Then what happens is then I've got CH3, CH2, CH3, CH, CH3, 3-bromo, so the bromo is going to be in the third carbon. No, so therefore the hydrogen will be here, and the positive charge here, lone pair of electron Br minus here, bonds here, and then you form there you go. Electrophilic addition, a double bond CH CH3, CH there, and then H3C, CH2, CH3, bonds to there, CH2, CH3, there you go. And that is for 5 marks, and the other 2 marks for explaining why more 3-bromo 3-methyl pentane form than 2-bromo 3-methyl pentane. So in this case, then you talk about carbocations. So I can see here 3-bromo, so let's say 3-bromo 3-methyl pentane formed from tertiary carbocation. 2-bromo 3-methyl pentane is formed from secondary carbocation, and then say tertiary carbocation is more stable than secondary carbocation. Either calculate show that magnesium is excess in this reaction. Magnesium. There we go. 396 milligrams, so 0.396 grams of the MR. 24.3. Last time I can remember, yeah, 24.3. And then moles of the ethanoic acid, which I'm just going to use concentration volume. 30 divided by 1,000 times by 30 divided by 1,000 times by 0.600. Work them out. No 0.018 moles. I can see it's a 2-to-1 mole ratio. Therefore, the moles of magnesium should be 0.018 divided by 2. And then do that minus 0.0163. No, sorry, 0.0163 minus 0.018 divided by 2. So I can say therefore 7.3 times by 10 to the power minus 3 moles of magnesium is in excess. Then it says sketch a line of figure 2 repeated using this much ethanoic acid. So in this case it's 30 centimeters cubed, so the moles of ethanoic acid in this case 30 divided by 1,000 times by 0.600, which I already did, so I don't know what I'm doing again. 0.018 moles. Then work out the moles of this. That's why it gives us space for working. Concentration of volume, moles concentration of volume, done by 0.800, which is 0.016. What's the difference between that? Well, it's only a bit difference. 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one's going to be 0.002. So 0.016 is just going to be, it's going to be a bit steeper. But then yeah, level out here. There you go. So something like that. And levels out on the 8th line up, yes. Below the 9th line. That is the end of section A.